What's up everyone, and welcome back to the Comms channel and the Radio 101 series. Today's video will be covering the different types of radio options available out there that you may run into. I've used a lot of these different types of radios over the years, and I'll cover their uses and pros and cons of each one. This video will be focused on receive-only radios, and the next video will cover ones that you can transmit on. Also, be sure to visit the post for this video on our website, where we have a buyer's guide matrix with key features and affiliate links to each radio so you can easily find a radio that meets your needs. We'll have a link to this in the video description. Before we get into it though, there are some terms that you may be unfamiliar with if you're completely new to radio that I want to quickly cover before we continue. The first one will be frequencies, and you can think of radio frequencies as the different channels on your TV or stations on your car radio. When you turn on your TV and change the channel, you're actually tuning to a specific radio frequency. And on your car radio, you can actually see what frequency you're on. You might have a music station on 92.5 that you like and a news station on 106.5, for example. And those are the frequencies of those stations. Most of the radio systems in this video use megahertz or MHz, but you may also see kilohertz or KHZ or gigahertz, GHZ sometimes. And 1,000 kilohertz equals 1 megahertz, and 1,000 megahertz equals 1 gigahertz. Next thing that might be new to you is HF, VHF, and UHF. And these are abbreviations for different frequency bands. Each of these bands has its own characteristics and uses for communications. We'll go more in depth in a later video on these. But we got HF, which stands for high frequency, and that's 3 megahertz to 30 megahertz. And this is a long-distance radio band. It's used for things like talking to people far away via ham radio or listening to international broadcasts from faraway countries. Next up is VHF, which is 30 megahertz to 300 megahertz. And this is a medium distance band, and it's used for things like your local FM radio stations, police, fire stations, airplanes, and more can be found in this range. And then next up is UHF, which stands for ultra high frequency. And that's going to be 300 megahertz to 3000 megahertz or 3 gigahertz. And this is a short distance band. Police and fire stations also use this range in addition to the VHF radio band. Things like your cell phone, Wi-Fi, FRS, GMRS radios, ham radios, and more can be found in this range. So scanners are the first type of radio we'll cover in today's video. And as mentioned in the intro video to the series, I got my start in radio with a scanner. This was just a crystal scanner, and I was locked into listening into whatever crystals the radio had in it. Scanners are much more advanced now and have the ability to have thousands of frequencies programmed into them. You may be familiar with the concept of programming frequencies with the radio in your vehicle and saving radio stations you like to listen to while driving. This is similar to what you would do with a scanner. And scanners are a great entry into radio if you're not worried about communicating with anyone yet, or you just want to monitor what's going on around you. And there's many things you can listen into with scanner. There's fire and emergency services, police, trains, aircraft, military, ham radio, FRS, GMRS, MURS, CB radio, marine radio systems, news agencies, and even more than that. Now, one important thing to note: if police and fire and emergency services are what you intend to listen to, you may need a higher end scanner that can receive digital signals, as many places have switched to digital. If not, then generally the cheaper analog scanners will do just fine. Even if they've not moved to digital, they may be on a trunked system, in which case a scanner capable of following trunk systems will be needed. But we'll cover that later in a video specific to scanners. You also want to check to see if they're using encryption. If so, you're out of luck and you won't be able to monitor them. Now, this wide range of what you can listen to are what make it a great start into radio before making the leap into a radio that you can transmit with. Having a scanner will allow you to listen to various radio services around you to see what's most popular in your area. For example, maybe FRS, GMRS is more popular than CB radio in your area, and it would make more sense to get an FRS GMRS radio instead. Scanners generally don't cover the HF frequencies, but some cover a small portion of it from 25 megahertz to 30 megahertz, which is where the CB radio and 10 meter ham radio bands are. Now, some scanner pros and cons. Some pros are they're easy to use. They're great for beginners as they're much easier than other radio systems to learn and use. Some of the higher end ones can be a bit more complex though. Some scanners have presets preloaded in them for scanning certain services like we mentioned earlier, like police, fire, ham radio, etc. And some of the higher end models can also load all of the frequencies for your area by just entering in your zip code. And the final pro is their standalone devices, unlike SDRs. They don't require a computer to be connected to them for use. Now, programming the more complex radios via computer is recommended, but once that's done, it can go back to just being a standalone device. Now, on to some cons for scanners. The first one's going to be their limited frequency range, and scanners are generally limited to a frequency range from 25 megahertz to 1300 megahertz. Now, this is where most radio traffic, most people are going to be interested in resides, so this is just a minor con on scanners. The next one is going to be their locked-in modulation. Scanners are locked into specific modulation depending on the band you're on. You're generally locked into AM mode for the civilian and military aircraft bands, and also AM for the CB and 10 meter ham radio bands. Everything else is typically locked to FM. The next type of radio on the list of receive-only radios are going to be shortwave or HF radios, high frequency radios. These radios cover the lower frequencies from around 1 megahertz, actually lower than 1 megahertz typically, around that to 30 megahertz. And what's neat about these frequencies is the signals can bounce off the ionosphere and back down to Earth. And this bouncing off of the ionosphere allows signals to travel very long distances, often multiple countries away. Communications on frequencies above HF, like in VHF or UHF, they're not able to bounce off the ionosphere, so they're limited to line of sight only. And there's many things from around the globe that you can listen to on these lower frequencies. Things like international broadcasts, which is going to be news, music, and cultural programs from different countries. There's ham radio, and these lower frequencies are popular with ham radio operators due to the long distances you can communicate on these bands. Then there's aircraft, and typically when aircraft are flying over the ocean and get beyond line of sight, they'll communicate on these HF frequencies. And that same thing applies for boats and ships. When they're out to sea beyond line of sight, they'll use these lower frequencies for weather reports, ship-to-shore communications, and also for distress calls in an emergency to provide their location to the Coast Guard. You can also listen to the military, the Coast Guard like I just mentioned, and the United States Air Force also use these HF frequencies heavily. And these radios are also good for gathering information during emergencies. You can listen to things like news broadcasts and weather broadcasts, and it's also heavily used by ham radio operators for emergency communications. Now, one important thing to note when looking for a shortwave receiver, you'll usually see options that don't include SSB, which is single sideband, or sometimes just referred to as sideband. And they only offer AM mode and sometimes FM. Now, if you're wanting to listen to more than just the international broadcasts and be able to listen to things like ham radio, ships, and the military, you'll need a shortwave receiver with SSB capability. Now, on to some pros and cons for shortwave radios. The first pro is going to be their global reach. Like we mentioned earlier, shortwave radios can receive signals from all around the world, which is something the other radios on this list are not able to do. The next pro is going to be their portability. Many shortwave radios are portable and battery operated, making them great for emergency and on-the-go use. And they're also affordable. The basic shortwave radios are usually more affordable than the high-end scanners or SDR setups. Now on to some cons. The first one is going to be their limited local reception. So while they're great for picking up signals across the globe, they don't pick up the local services like police or fire and emergency services that the scanners and communications receivers are able to. And this is due to their narrow frequency range. They're usually limited to just the HF bands from 1 megahertz to 30 megahertz. And next up we have software defined radio, or SDR. Now these have been a great advancement in radio technology, and they offer an increased level of flexibility and a wide range of applications. And this is due to them being software-based systems rather than hardware-based. In conventional hardware-based radio systems, any new capabilities required hardware modifications or additions. But with SDRs, new functionalities are enabled through custom software development, and this opens up opportunities for a wide range of applications. For example, the ADS-B flight tracking setup I did a video on uses SDRs to receive data from aircraft for tracking. Another example is receiving digital voice communications like P25, DMR, or D-Star. And there's even software to pick up signals from weather balloons and track them. The sky is really the limit when it comes to SDRs, and the technology has even made its way into some traditional radios like scanners, and even some ham radios are SDR based now. Now the frequency ranges vary greatly depending on the SDR, but they generally cover VHF and UHF. Some advanced SDR models like the SDR Play extend their coverage to include HF frequencies. Many SDR programs include what's called a waterfall, and this allows you to see the signals you're picking up as well as signals on the surrounding frequencies in real time. You can also see this feature on the higher end ham radios and communications receivers. Having this feature has been a game changer for me, and I generally seek out radios that have a waterfall on them. Now on to some pros and cons for software-defined radio. The first pro is going to be their flexibility. Like we mentioned earlier, these are based on software, making them extremely flexible, and they have a wide number of applications due to this. The next pro is going to be their cost, and SDRs themselves can be found relatively cheaply. But since they do require a computer, the cost does go up if you don't already have a computer and need to purchase one. But you can usually find an SDR from around $30 to $35 or so for a cheaper one. The final pro is going to be their digital capabilities. So digital scanners can be costly, like hundreds of dollars. So if you already have a computer, an SDR is the cheapest way to receive digital voice signals like P25, DMR, D-Star, and more. Now some cons for SDRs is they can be complex to set up if you're not well versed in computers. They're not standalone devices like scanners are and do need a computer to operate. And they can be a costly system if a computer does need to be purchased. And last but not least, we have communications receivers. And these devices do share similarities with scanners, such as the ability to program frequencies into channels and scan through them. However, communications receivers offer a higher level of capability. Starting with frequency coverage, communications receivers offer a much wider range of frequencies they can tune into compared to scanners. Let's consider the ICOM R8600, for example, which can receive signals from 0.010 megahertz to 3000 megahertz. Even the most advanced scanners on the market today typically cover a range of only 25 megahertz to 1300 megahertz. They also don't have the modulation limitations that scanners do. Scanners, like we mentioned earlier, are generally limited to AM and FM and don't allow you to change what mode you're in. Communications receivers, on the other hand, generally have AM, FM, LSB, USB, CW, and sometimes even more modes than that, and they let you select the mode regardless of what frequency you're on. One example where this is helpful compared to scanners is the 10-meter ham radio band that some scanners can pick up. Much of the communications on this band are in USB mode, and scanners would not be able to pick this up. Scanners do have an advantage over communications receivers though, as they can monitor what are called trunked systems. I won't go too deep into trunking in this video, but just know that many police and fire EMS agencies use trunked systems. So if monitoring those are your goal, you'll want to check to see if they're using trunk systems in your area. If so, you'll need a scanner with trunking capabilities to pick them up. Now, how to check what is being used in your area will be covered in another video specific to scanners. Now, there's more I can get into, but there will be a future video covering scanners and communications receivers more in depth. But to put it simply, scanners are more for scanning a set of frequencies that you're interested in and letting it sit there. Communications receivers are more for sitting at the radio and tuning around the bands to explore what's out there. Now on to some pros and cons for communications receivers. The first pro is going to be their wide frequency range. Communications receivers are able to pick up more frequencies than the other radio systems we covered. They also have better sensitivity and selectivity compared to scanners, which results in clearer reception. And they also have the additional capabilities, like we mentioned, with the single sideband modes of LSB and USB. Now on to some cons. The first one's going to be they don't come with any sort of programming. So scanners, for example, you can get them that have a button for listening to police or fire and emergency services, ham radio, F4S, GMRS, or trains and more things sometimes. Communication receivers typically don't have this option, and you'll basically just need to know what frequency ranges these things are on and monitor these yourself. And the final con is going to be their cost. They are typically much more expensive than what scanners cost. That'll do it for this video on receiving communications. The next video will be on radios you can transmit with, so stay tuned for that one. And if any of these radios seem like a good fit for you, be sure to check out the affiliate links in the video description below, and I'll also have links to these on the website. Hopefully you found this video informative and useful. If so, please be sure to give this video a thumbs up and subscribe if you haven't already done so. Thank you all and have a good one.